So in the last video we saw some common trigonometric ratios of some specific angles that are important from the perspective of triangles. However, in this video we would expand the trigonometric ratios or the trigonometric ratios to trigonometric functions. So I'll briefly introduce what functions are without going into much depth of set theory, relations, binary operations, and so on and so forth. So I'm assuming that one, you don't know set theory. And at the moment, secondly, you aren't familiar with real numbers. However, if you are familiar with set theory and you are familiar with real numbers, then I would urge you to pick up some book on higher mathematics, like maybe the ones by Cengage Publications or by or any Olympiad book or any higher mathematics books. And even if you don't have a book, I would suggest that the best thing is to go on the internet, use some a generative AI like maybe ChatGPT or Gemini to get a much more technical definition of a function. But if you, but obviously if you don't know the set theory or the concept of real numbers, I would say that functions are simply a sort of a black box. What does a black box means is that it take or simply a machine or a processing unit which takes an input and gives an output. So the operation can be very simple. Let's say input is typically denoted by x and output is typically denoted by y. So it can simply be either of the form. Let's say you take the input and you add 3 to it, right? This can be a possibility. The other possibility is that you raise it to some power, let's say x square, or there's a possibility that you have some complex functions like log or the exponential function, the logarithmic function, or there are many things that can be applied to the input. Just like there are many processes in the world. So for instance, the food processing unit is very different from, let's say, the machinery that is used to produce the automobiles. So quite literally, like as in the real world, the car machinery or the parts of the car is simply scrap metal or metal, stainless steel, carbon fiber, and it goes through a process as like this black box, and the output is a car. Similarly, in the food processing unit, the raw materials are simply the fruits and vegetables, maybe some additives, some sugar, etc., and it goes through the food processing unit, and the output is, let's say, the packaged food, that is maybe chips or juices, etc. So that food processing unit and that car assembly in the factory, these are the equivalents of this black box that we call as functions. It is typically denoted by, let's say, f and f of x. X in close brackets means that the function is being applied on input x. So f of t would mean that function is being applied on this variable t. Just like the functions that I have mentioned here, a type of function is these trigonometric functions. So in the last video, I had introduced, or maybe in the last to last video, I had introduced trigonometric, trigonometric um terms as ratios very specific to triangles. Uh, but but in this module, in this video, we try to expand it to a general term, that is for any input. And what kind of input it is? An input that belongs to the set of real numbers. Real numbers is made up of two types of numbers, that is the rational numbers and irrational numbers. Even without you knowing the formal definition of rational numbers, all the numbers that come to your mind are actually rational. The irrational ones um, are those which well, typically you don't come across them. For instance, root 2, root 3, e, pi. These are the numbers which have a non-ending decimal expansion. Uh, uh, anyhow, anyhow, it's not that. So these two, rationals and irrational, make up real numbers. However, for the sake of defining a real valued functions, or the trigonometric functions rather, I'm just highlighting these real numbers, but I don't think it will have any consequence um, in your understanding the trigonometric function, even if you don't fully uh, grasp the concept of real numbers. So functions like the trigonometric functions sin x, y is equal to sin x, y is equal to cos 6, and y is equal to tan x, uh, tan x are all real valued. What does a real valued function means? Real valued function real valued functions are simply those whose output, that is y, belongs to the set of real numbers. It gives a real number as an output. That's what real valued functions are. So all trigonometric functions are real valued. So obviously in a later video we will add 3 more trigonometric functions to it, but these are the basics, and the others are simply the extended form of these basic trigonometric functions. Uh, so consider sin x. Now y is equal to sin x is a function of the form. Now, how do we define the trigonometric functions? Because uh, there's possibly no triangle that is associated to it, or I mean, it is possible that there are different triangles for which one of the angles is x. Well, obviously, this x is an angle, a degree of rotation. So you observe that, regardless of the size of the triangle, of that right angle triangle, if you have one of the angles as x, then this is the first triangle. Let's say this be h1, hypotenuse 1, and this be the perpendicular one for triangle 1. This be h2 for the second triangle, hypotenuse for the second triangle, and let's say the last one be h3, and p3. Now in all the 3 triangles, you'll observe that p1 by h1 is equal to p2 by h2 which in turn is equal to P3 by H3. So regardless of the size of the triangle you choose, if one of the angles is x, and by triangle I mean a right angle triangle, so irregardless of the size, the ratio always remains the same. So, and why is it the case? You will understand it later when we discuss similar triangles. The proof comes from similar triangles. So what does it so anyhow, what does it mean for or what is the point of the ratio being independent of the size of the triangle? It is the fact that for our convenience we define a unit circle. A unit circle is the one for whom the radius is equal to 1 unit. So this is a unit circle. Now what you do is that you take a base, so this is the center O, and obviously this is the, let's say, the horizontal base, and you measure x degrees. Let's say for our convenience till this, for this for our convenience or for simplicity, I'll restrict x between 0 and 90 degree. So 90 degree is this, so x can move anywhere, so x can go anywhere in between, so any value between these, this x can take, right? Let's say for some value, this is the x, right? This is the ray. Now this is the point where the ray intersects the circle. Let this be A. You drop a perpendicular from A onto the base, the horizontal, let this be B. So you now have a triangle OAB which has a unit radius, right? And obviously AB perpendicular to OB, so this is there, this point be R, there's no point, yeah, so this is R. Now in this triangle, when you calculate sine x, what is it? It is AB upon OA, and OA is 1 because it is a circle of unit radius. So sine x is simply AB, right? So when you calculate, when you input x for all the possible values that can exist between 0 and 90 degree in a continuous fashion, you'll observe a graph of the sort this is 0 degree and this is pi by 2, which is 90 degree. So you'll observe that the sine goes from the 0 all the way to this in a very cyclical fashion. Just a minute. So yeah, so it goes from 0 to pi by 2 in a very cyclical fashion. So we will stop it here and we'll continue it, or rather I'll further expand this graph of sine in the next video.